Okay, so when we looked at the different lengths of our waves and the frequencies, our biggest conclusion was just that our last note here. As EMR, or light, becomes more energetic, the frequency will increase and the wavelength decreases it, allowing it to behave more like a particle than a wave. So if we look at your spectrum there, okay, your spectrums, these ones, yeah. As it increases in the energy, okay, and increases in frequency, decreases in wavelength, this type of radiation at this end of your scale is going to be more particle-like. Like it's going to demonstrate more particle-type properties. And then over here, where we're looking at radio waves and microwaves, those are going to display more wave-like properties. So EMR, as we've talked about, has both particle and wave properties. Okay? And it's kind of cool because light is almost like right in the middle there, like the light we can see. Okay? And so we can look at visible light and how it's both wave and particle, and then when we kind of go outside of there, okay, so this is more particle-like, this would be more wave-like. Okay? Now, monochromatic light, mono means one, yeah, is light consisting then of a single frequency. Or wavelength. White light, like the light that we see, is not monochromatic because it consists of a bunch of colors, frequencies, and wavelengths. So how can we see different colors in just normal white light? How have you seen that displayed before? A prism, okay. Yeah? Just white light. Like, how do you know that there's red, orange, yellow, green, blue? A rainbow? Yeah? Okay. Which one of those? Show the rest of the group. Okay. So twist it around, right?
It's like a disco ball. Yeah, Maureen's colorblind.
What color is your sweater?
Purple?
So, you know, something simple like that, you can see all of the different colors, even though it's just normal white light hitting it, so that we know that our white light, the white light is not monochromatic. Okay, so now, so how can we see this? So we looked at CDs, prisms, rainbows, okay, where you can see the light reflecting and showing all those different colors, which is really cool. Okay, so now let's talk about the formulas that you will be using. Now, as I said, we have two different ways of looking at light. So light is a type of EMR. So when we're talking about this, these two theories apply to all of EMR. So the first theory, as I said, is wave theory. Okay? Or that's called classical physics, uses the wave theory. So when we think of a wave theory and waves, the way this applies is that it is a stream of transverse waves radiating outward from a source. Okay? Now, what is our evidence that waves behave, or that light behaves like this? Well, we see different things happening like this: interference, diffraction, refraction, and polarization. Now, each one of these things we are actually going to investigate in a little bit more detail throughout this whole unit. But let's just look at one of them to start with. Let's think about polarization for a minute. So, I'll give you a couple polarized lenses. We'll do a little experiment. You don't have to. Might work with